All right, let's get into it. We all want to build apps that just work, right? But what does it take to build something that doesn't just work when things are good, but can actually take a punch and keep on going? Well, today, we're going to build an unbreakable application, piece by piece, using this really powerful idea, the pyramid of resilience on AWS. But first, just think about this for a second. When your app goes dirk, what's the real damage? It's not just some error message on a screen. For an e-commerce site, that's lost sales, plain and simple. For your own teams, it's a broken tool that stops them from doing their jobs. And for your users, it's a loss of trust. See, the cost of downtime isn't just a tech problem, it's a business problem, measured in real money, broken workflows, and a reputation that's tough to get back. So the goal here is what we call architectural resilience. And this isn't about trying to prevent every single failure, because guess what? Failures are going to happen. Hardware dies, networks get flaky, someone pushes bad code. It's inevitable. Resilience is all about designing a system that expects failure, absorbs it, and just keeps on chugging along for your users. So how do we actually do that? We're going to build our super resilient app from the ground up, climbing this pyramid one layer at a time. We'll start at the bottom with the basics, like surviving a single server crash, and work our way all the way to the top, where we can withstand huge regional disasters and even achieve true global scale. Ready? Let's start at the foundation. Okay, layer one. This is all about protecting the individual Lego bricks of your application. Think a single EC2 instance, which is just a virtual server in the cloud, or a single worker process, or one little database node. The question is, how do we make sure that when one of these little pieces fails, it doesn't bring down the whole castle? And this right here, this is the picture of so many outages. On the left, everything depends on that one single block. If that block, your server, kills over for any reason, while the result on the right is pretty much guaranteed, the whole application shatters. This is a classic textbook single point of failure, and it's what we have to fix first. So the first step is to break those tight dependencies. And one of the most powerful ways to do this is by decoupling your components with a service like Amazon SQS, the simple queue service. Just think of it like a digital mailbox that sits between different parts of your app. Instead of a web server directly telling a worker to do something, it just drops a to-do message in the SQS queue. Then a separate worker comes along and picks it up. Now, here's the magic. If that worker instance crashes halfway through its job, the message isn't lost. It just pops right back into the queue, ready for another healthy worker to grab it and finish the job. So what are our rescue tools for this layer? Well, think of EC2 auto-scaling as this little robotic medic. It's always watching, and the second it sees a server get sick, it automatically swaps it out with a brand new healthy one. Now, for this to work smoothly, our servers can't be holding on to any important information. They need to be stateless, and we do that by moving session data into a central service like Elasticache. And for the hard drive, we use something called EBS, or Elastic Block Store. It's like a network-attached hard drive that we can just unplug from the failed server and plug right into its replacement. No data lost. All right, we've handled single components. Let's level up. Now we're planning for a much bigger failure. What if an entire data center goes offline? Because of a power outage, a flood, a network issue. In AWS terms, we call a data center an availability zone, or AZ for short. The solution here is actually pretty simple in concept, but it is incredibly powerful. You just don't put all your eggs in one basket. A single AZ architecture is brittle, it's fragile. But a multi-AZ architecture, where you spread your application across 2 or more data centers, well, that's resilient. If one of those AZs goes down, your app doesn't just survive, it thrives, continuing to serve your users from the healthy zones without even missing a beat. And of course, AWS gives us the perfect tools to do exactly this. Your application load balancer is key. It's designed to spread traffic across servers in multiple AZs. And for your database, this is absolutely critical. Amazon RDS has a multi-AZ feature that creates a perfect, live, continuously updated copy of your database in a different AZ. It's a lifesaver. And if you need shared files, services like EFS and FSX are built from the ground up to be available across multiple zones. And this right here, this gets to the absolute core of why this is such a game changer. The key word is synchronous. When your app writes something to the database, the transaction isn't considered done until it's written to the database in both data centers. So what does that mean? It means if your primary data center fails, you have a recovery point objective, an RPO, of 0. That means 0 data loss. It is one of the single most powerful resilience features you can just flip on. Okay, Time to climb higher up the pyramid. What's the plan for a truly massive disaster? I'm talking about an event that could impact an entire geographic region, like a hurricane, an earthquake, or a major internet fiber cut. This is the world of disaster recovery, or DR. When it comes to DR, you've got options, and this table breaks down the big trade-off you'll always face. You got to pay attention to two key metrics. RTO, the recovery time objective, that's how fast you need to be back online, and RPO, our old friend, the recovery point objective. That's how much data you can afford to lose. As you move down this list, from a simple backup and restore to a full-blown active-active setup, your recovery time and data loss shrink to almost nothing. But take a look at that cost column. It climbs, and it climbs fast. This isn't just a technical decision, it's a business decision. And to pull any of these strategies off, you need the right toolkit. S3 cross-region replication is fundamental. It just automatically copies your important data to another part of the world. Same for your servers. You need to be copying your EBS snapshots to your DR region. And the master switch that makes this all happen, that's Amazon Route 53. Think of it as the air traffic controller for all your users. It's constantly doing health checks, and the moment it sees a problem in your main region, bam, it automatically reroutes all your traffic to your healthy DR region. And since we're talking about keeping data safe, it's worth just pausing on this number for a second. S3 is designed for 11 nines of durability. What that means is if you stored 10,000 files in S3, you could expect to lose maybe one of them every 10 million years. This is the bedrock that all resilient data strategies are built on. Your data is just incredibly. And just like that, we've reached the very peak of the pyramid, global resilience. And up here, our definition of resilience actually gets a little broader. It's not just about surviving outages anymore. Why? Because from your user's point of view, an application that is painfully slow is just as broken as one that's totally offline. Performance is a form of availability. The name of the game up here is getting your app physically closer to your users all around the world. And we do that with the AWS Global Edge Network. CloudFront is the CDN. It caches your content in hundreds of locations globally so it loads lightning fast. Global Accelerator optimizes the internet path, routing your users over the private, super fast AWS network. And Route 53 can do something called latency routing, where it intelligently sends each user to the AWS region that will give them the absolute fastest response time. And remember Route 53, our air traffic controller? It's not just for disaster recovery, it's the director of all our global traffic. And the reason we can trust it with such a critical job is because AWS backs it with a 100% availability service level agreement. It is the one service that is engineered to never, ever fail. Wow. Okay, so we have climbed all the way from protecting a single lonely server to managing a full global presence. Let's take a breath and just quickly summarize the essential tools that are now in your Resilient Architects toolkit. So let's just run back down the pyramid real quick. At the base, for component failures, we use decoupling with SQS and auto-healing with auto-scaling. To handle zone failures, we built across multiple data centers, using Multi-AZ for our databases and load balancers. For regional disasters, we chose a DR strategy and used tools like S3 replication and Route 53 failover. And at the very peak, we got global performance with the AWS Edge Network. And of course, wrapped around all of this are the absolute essentials: security to protect against attacks, and automation so we can rebuild everything perfectly every single time. And if there's one thing to take away from all of this, it's that resilience, well, it doesn't just happen. It's not an accident. Building an application that can withstand failure is a series of deliberate choices you make as an architect. Every service you pick, every pattern you implement, it's a conscious decision that moves you further up this pyramid. So, as we wrap this up, I want to leave you with this question. Take this pyramid and apply it to your own work. Think about your most critical, can't-go-down application. Where does it sit on this pyramid right now? Is it ready for a server to fail? What about an entire data center? Answering that question honestly is the very first and most important step you can take towards building truly unbreakable applications.